Hi, my name is Bhaskar Jha. I am a graduate from IIT BHU, Varanasi. I teach students for IIT JEE and medical, and my primary subject is physics. Today's topic is projectile motion. Have you seen the motion of cricket ball when it is hit by the batsman? It goes all the way to the boundary. Have you seen javelin throw or simple shot put throw? Even we can take this example. If you observe the motion of this cap, it goes at an angle with the horizontal. This kind of motion, which is horizontal as well as vertical, is a two-dimensional motion, and such a particle is called projectile when it moves under constant acceleration in vertical direction. Let's see the projectile motion on the board. Let's take y-axis as the vertical direction and x-axis as the horizontal direction. The particle is projected from the origin with an initial velocity u at an angle theta with the horizontal. The particle moves on a curved path known as projectile, and it lands on the ground after some horizontal range. So let us examine this kind of motion. How do we deal with it? What do we do here? We break the two-dimensional motion into one dimension each for horizontal as well as vertical. So the first thing that I'm going to do here is take the components of the velocity. So what I get is u cos theta and u sin theta. So I do the analysis separately for x-axis and y-axis. So let us see the initial velocities. Initial velocity along x-axis is u cos theta, and initial velocity along y-axis is u sin theta. The only force that is acting on the particle is the force of gravity, mg. So there is no acceleration in the horizontal direction. I am assuming we are neglecting the air resistance. And in the vertical direction, it is minus g. Why minus? Because u sin theta is taken positive, so this has to be negative. It's downward direction. So using these two and using the kinetic equation v equals to u plus at, I can find the velocity along x-axis and velocity along y-axis. As we can see that the acceleration along x-axis is 0, it simply means that velocity along x-axis is constant, and it is u cos theta. Means the particle can be anywhere in the projectile. Its velocity along horizontal is always u cos theta, no matter whichever point we take. And what about the vertical velocity? It keeps changing as u sin theta minus gt. So as the particle goes up, the velocity decreases, and at the highest point, the vertical velocity becomes 0. After that, the vertical velocity is in the downward direction, and when the particle hits the ground, it hits with the same speed as the initial speed, u. Now, let us find the time of flight. Time of flight is the total time of the journey. So, by symmetry we can say that the time taken by the particle to reach the maximum height is half of the time of flight. This is the point where vertical velocity becomes 0. So, Vy equals to 0 means u sin theta minus gt equals to 0. So, the time of ascent that I get is u sin theta upon g. This is the time taken by the particle to go to the maximum height. It takes the same amount of time to come back to the ground. So, the time of flight is given by 2u sin theta by g. This is the first and the foremost equation that we need to remember. Let us examine this problem. A particle is projected at an angle theta with initial speed u. we need to find the time after which its velocity is perpendicular to the initial velocity. So, if you go by the diagram, it's something like this. The particle was thrown at an angle theta, and after a while, this is the initial velocity. Its velocity has become perpendicular to the initial velocity. So what is the time that we need to find out? Let us make use of vectors. So the initial velocity, I can write it as a vector u cos theta I cap plus u sin theta j cap. And final velocity, as I know that the horizontal velocity remains constant, u cos theta I cap plus the vertical velocity changes minus gt, j cap. Now, these two vectors are mutually perpendicular, hence their dot product is 0. I'm using the property of the perpendicular vectors. So when I take the dot product, what I get is u square cos square theta plus u square sin square theta minus u sin theta times gt equals to 0. Now, u square cos square theta plus u square sin square theta makes it u square equals to u sin theta times gt. Hence, my required answer is t equals to u upon g sin theta. This is the time after which the velocity will be perpendicular to the initial velocity. Thank you.